Okay, dear students, so today we'll be doing furthermore MCQs on what? On alkyl halides, which is your part 3. Okay, part 3. Okay, so now question number 1 is, which of the following is known as Westrosol? We have already discussed this. Okay, so see my previous MCQs, you will be understanding that. Okay. Okay, so let us now understand question number 1 as an alkyl halide. An alkyl can be converted to alcohol. Can be converted to alcohol, but okay. Option number A is addition. Option number B is elimination. Option number C is substitution. Option number D is dehydrogenation. So we know that substitution can actually, so when this X is substituted, but this X is replaced or substituted by OH minus, then this forms ROH. So this is actually substitution reaction. Okay, so question number 2 is given that A, when reacted with KCN, right, that is your alcoholic KCN, this gave B, which on hydrolysis produces CS3COOH. So A and B are option number A is CS3X CS3CN, B is CS3CN, CS3X, C is C2H5X and CS3X, and D is CS3X and C2H5CN. Okay, so remember, let us try from here. What happens when CS3X is reacted with KCN? This will give CS3CN, which is your A. And when this is hydrolyzed, complete hydrolysis will occur, then this will give you CS3COOH. So look here, so this is B. So actually in question this is, and so this is the product, so final product is matching, so A should be this, and so this is B. Okay, this is A, so A should be this and B should be this. Option number A is the correct. So now let us go to question number 3, and that is your okay, an example of Carr's effect. An example of, that is your Carr's, this is Carr's effect. Carr's, that is actually talking about anti-Markovnikov's effect, right? So the option number A is 1-butene plus HBr gives 2-bromobutane. B is 1 butene plus HBr gives 1 bromo butane, or C number, that is your 1 butene plus HBr H2O2 peroxide, 1 bromo butane, and D number 2 butene 2 butene plus HBr gives 2 bromo butane. Okay, so let us see here. So the actual answer is C, option number C, as we have discussed in the previous slide. Side effect is only seen in case of SBR, right? So the product this use when you use here, then this one will be right. Okay, see my previous video, you'll understand why has this happened. So question number 4. Chloroform when boiled with caustic soda. Okay, yeah, when chloroform is boiled with caustic soda, okay, solution of caustic soda, it gives A number, that is your formic acid, B number, which is your sodium acetate, C number, that is your potassium acetate, or D number, that is your acetic acid, that is your CH3COOH. Okay, so for this you need to remember it gives formic acid. Okay, so question number 5. Okay, question number 5 says the reaction CH3 CH2 Cl when reacted with OH minus gives CH2 plus water plus Cl minus. This is actually dehydrohallucination reaction, right? Dehydrohallucination reaction. So this is your option is hydrolysis. Option B is dehydration. Option number C is beta elimination, and option number D is actually your hydrohallucination. So this reaction is actually dehydrohallucination, not hydrohallucination. This reaction is actually dehydrohallucination, but this term is not given in the option. So you should remember beta elimination. Actually this is also partially correct. Actually this is alpha beta elimination. So from alpha carbon this chloride is removed, and from the beta carbon hydrogen is removed. So this is alpha carbon, this is beta carbon, right? From here hydrogen will be removed, and from this chlorine will be removed. So this hydrogen with OH minus forms water, and this Cl minus is liberated, right? Cl minus is liberated. If we had used KOS, then this would have formed here KCl, right? So this is alpha beta elimination. If not given, beta elimination is the correct answer. So let's do question number 7. That is your, which of the following alkyl halide is used as methylating agent? Which of the following alkyl halide is used as methylating agent? Okay, so the option number A is CS3I. Option number B is C2H5Cl. Option number C is C2H5Br, and option number D is your C6H5Cl. So important point is, among this one, look here, among this one, iodine, chlorine and bromine. So better Lubin group is iodine, then bromine. This is first, this is second, this is third. Okay, so if I have to choose an option from here, these three, then I would choose this. Now this 2 is eliminated because better Lubin group is iodine. Okay, so methyl will be produced over here, can be used as better methylating agent from here and here. So now what if I have to choose between this and this one? Look here, when chlorine is removed from here, so this positive charge on the benzene itself, can you see, this cannot delocalize, cannot delocalize, right? Delocalize, right? Because this can there is no alternate double bond, right? Positive charge, then there would be double bond either this side or this side, so it cannot just be moving into the benzene, right? So this charge cannot be delocalized, so this is unstable, this is unstable, right? This is unstable, so the better option is this one. Okay, CS3I. Question number 8. Phosgene is common name for, you know, this is phosgene, and this is called carbonyl chloride, is also called phosgene. Okay, so now let us see here, carbyl amine test is performed in alcoholic KOH by heating the mixture of, so you should remember this is just a reaction. Okay, we react actually primary amine, this RNS2 should be primary, or you could use C6H5NH2. Okay, in the presence of alcoholic KOH with, this is your chloroform, right? This will produce what? RNC or C6H5NC, which has fall order. This is actually the test for primary amine. Okay, test for primary amine, and this will produce isocyanate. Okay, this will produce isocyanate. Okay, so the next question that we are going to do right now, question number 10, is chloroform is kept in brown bottle. Again, it is just to be remembered. Why is chloroform kept? Chloroform is kept in brown bottle because it is oxidized to phosgene, that is a poisonous gas, in presence of light and air, right? So it should be kept in the brown bottle. Okay. Question number 11. Haloform reaction is used for prepare. Okay. This is also, you can just read, haloform reaction is used to prepare. Okay, you can tell me. A number is CHCl3, B number is CCl3 dot 2, C number is your C2H5Cl, and D number is your CCl3.CH4 chloral. So we know haloform used to prepare chloroform, right? Question number 12. That is your, when iodoform is treated with the AZ dust, that is your silver dust, silver powder. When chloroform, or you can say iodoform, okay, iodoform is treated with AZ powder, it gives option number A, ethane, B, ethene, C, ethine, or D, that is your acetylide. Okay, like this you have been said. So first of all, we know that CHCl3, or let's say CHCl3 or CHI3, when reacted with AZ, okay, two molecules of these two, so this will be reacted to form what? AZI, right? AZ will react with AZI plus HC, give HC triple bond CH. This is one of the method of preparation of alkyne, right? We have read already in alkyne chapter. So this is ethine is the correct answer, right? This is also called acetylene, okay? Acetylene. So now question number 12 that we'll be doing over here is your, which of the following is Borodin-Hunsdiecker reaction? I have already discussed in the previous chapter. Which of the following is liquid at the room temperature? Okay, which of the following is liquid at room temperature? Okay, so option number CS3 BR, B is CS3Cl, C is CS3F, and D is CS3I. I have already discussed CS3X, whether X could be fluorine, chlorine, or bromine. These all three are gases at room temperature. But CS3I is what? Liquid at room temperature, right? But you may be confused, like CHI3, between this and this. So this is actually crystalline solid. Iodoform is crystalline solid at room temperature. Okay, you must understand this. So now with 13. Okay, which of the following will have maximum boiling point? Which of the following has maximum BP? So the option number A is C3H7Cl, C3H7Br, C3H7I, or C3H7 okay, fluorine. So we have already seen that whether it is density or boiling point, that is always directly proportional to the molecular weight of halogen if R is same. R is same. Look here, R in each case, this is R, this is R, this is R, this is R. R in each case is C3H7. So now halogen, so iodine, weight of iodine is more than bromine is more than chlorine is more than fluorine. So ideally 3H7 iodine will have more boiling point than C3H7Br, then C3H7 Cl at C3H7F, right? So this is the correct answer. If you have to say electronegativity order of this one, then electronegativity order is fluorine, chlorine, bromine, and iodine, right? This is electronegativity order of this one. We have to compare dipole moment, dipole moment among these. Then C3H7Cl will have more dipole moment than C3H7 fluorine, then C3H7 this is your bromine, and then C3H7 iodine. This is the order of the dipole moment. Why? Because CC bond, okay, CCl bond in case of this one is more than this one. Okay, and dipole moment is actually the electronegativity that is your difference, right? Delta electronegativity difference into the actually the length of this CCl bond, right? Length of CCl bond. So you must understand this. So next is question number 14 that we are going to discuss over here. Alkyl halide bond with alkyl halide burn with option number A is your smoky flame, option number B is your okay, this is your yellow flame, C is your green flame, and D is your blue flame. So we have already read that alkyl halide actually burn with green flame, okay, on the copper wire actually. So question number 15 that we are going to discuss over here is an organic, okay, which of the following undergo hydrolysis readily? Which of the following undergoes hydrolysis lysis easily. Okay, so option number A is, this is your actually CH2 double bond CH2 Cl. B number is CH2 CH2 Cl. So CH3 C2 CH2 Cl, and D is your C6H5Cl. So during hydrolysis, what will happen? This this Cl will be removed from here, right? This will be removed from here, and now carbocation will be formed, right? Carbocation will be formed. So if I say this is the carbocation, suppose, then this is unstable because this plus charge cannot delocalize from here. So in case of B, suppose this is CH2 double bond CH2 plus. So look here, this will move like this and this will move like this, right? So here positive charge will actually delocalize, right? So here this is CH3 CH2 CH2, this is actually plus R effect is shown from here, plus I effect is also, plus I effect is seen from here. So look here, but here in this case this again cannot delocalize from here. So which will uh, directly hydrolyze? That one which is more stable, in which positive charge is more localized, right? So actually this will be readily hydrolyzed. After that this will be, this is first, okay, secondly this will be easily what, uh, hydrolyzed. Okay, so our answer is option number B. So let us come to question number 15. So asked here, Finn-Kelstein reaction. Finn-Kelstein reaction. So this is nothing, we prepare iodoalkene from here, that is your, suppose this is your R CH2 Br, then we react this with NaI in the presence of acetone, okay, from R CH2R. This is what Finkelstein reaction is, okay, that's it. So an alkyl iodide get darkens on standing because of liberation by air. That is your iodide will be liberated from there and that will be changed into dark. Okay, next. Okay, tell me, under the name pyrene, what we use? That is your CCl4, and this is used as fire extinguisher, right? Extinguisher. Okay, now we have been asked chloritone is, so we know that this is CS3 COH CCl3 CH3. Okay, you must remember this one. Okay, this is chloritone. Question number 18. Tear gas is, how we prepare tear gas? Actually, when we react this with HNO3, this will give you CCl, okay, CCl3 and O2, CCl3 and O2. Okay, so this is actually called as chloropicrin. Okay, question number 19. Okay, which of the following is, okay, war gas? This is also used as war gas. Okay, this was used in war, chloropicrin, so it is also called war gas. Okay, that's it. Now, which of the following give white PPT with ethanolic agent? So this is very important question. Okay, which of the following gives what? White PPT. White PPT with ethanolic, ethan 3 and O3 immediately. Immediately. So the option number A is CS3, CH2, CH2Cl. Option number B is CS3, CH2, CS3. Option number C is CH2 double bond CH, CH2, Cl. And option number D is CH3, CH double bond CHCl. Okay, so again we see if chlorine is removed means look over here, this gives AgCl as white PPT, right? AgCl as white PPT. Suppose if Cl is removed from here, carbocation forms. Okay, second, this is your alkane, so I'm removing this. This is no option. Okay, now let us see here. If I remove chlorine from here, so positive charge will be here, and chlorine from here, then positive charge will be over here. So once think wisely, which will be more stable? This one, because this positive charge delocalize over here. But here, look at positive and double bond. This is unstable. Again, this is showing plus I effect over here. So somehow, secondly, this will react more. So firstly, this will be the answer. That is your allyl chloride. Allyl chloride will be the answer, right? Are you getting it? Okay. So we'll be doing next MCQs in another part. Okay. There are more MCQs to do. Okay. Thank you for